Today we're doing Math 3, Unit 1, Section 6. We are talking about piecewise functions. Does anybody have any idea what piecewise might mean? Parts. Piecewise actually does mean parts. We're taking parts of different functions and putting them on the same graph. Okay? So, hopefully if you struggled yesterday, that when we go through some of this stuff today, it will actually help you better understand yesterday's assignment. So if you notice here, there are two different functions that we're going to end up putting on the same graph. You'll also notice that this one is saying less than or equal to 3, and this one is saying greater than 3. Please note that you can only have one equal to sign for a function. So only one of the numbers can have an equal to for that function. Do you guys remember back like in the other classes that you took for math? And do you guys remember how you would check to see if something was a function and you would use the vertical line test? Do you guys remember that? In order for something to be a function, it has to pass the vertical line test, where it can only hit one point on a graph if you were to draw a vertical line. Are you guys recalling this? Some of you know. Okay, anyways, so if I had a solid point at one point on the y and then another solid point, it wouldn't be a function because it's hitting 2 points at the same time. And so this is why only one of them can have the equal sign. So we're going to look at these separately, but one thing I might ask you to do that will help you a little bit is make boundary lines. And we're just going to do like a dotted line, and this is to remind us on our graph. So if you notice there, I'm putting a boundary at 3. It's just going to remind me that the graph is going to change at 3. Okay? So to the right of 3, the graph is going to look like something, and to the left of 3, it's going to look like something different. And so that will kind of hopefully help you remember that something's going to change at that point. So if we start with this first function, when you look at that, do you know what kind of function that is? Linear. It's linear. It is a line. And how do I know that that is a line? Because there's no squared term. You have a y and an x. That's in the form y equals mx plus b. And I'm going to actually write this as y equals negative 1/3 x plus 2. Anytime you don't have a squared term or an exponent, you just have a value for y and x, that is linear. So if you're graphing this, what is your slope and your y-intercept for this? Good. M equals negative 1/3, and my y-intercept is at positive 2. Okay. And if you want to, we could go to our graph right now and plot those points on there. So my y-intercept is at 2. Okay. So I'm going to go up to 2 and make a point. My slope is negative 1/3. So from this point, what do I do? Down 1, right 1, 2, 3. Now, I notice that's actually on my boundary line. Do you guys see that? So I need to pay attention. Is it going to be open or closed circle? So if you go back and look at your function at 3, is it going to be open or closed? Closed. How do I know it's closed? Very good. It has that line underneath. So I'm going to have a closed or solid point there at down 1, right 3. And remember, we can also go the opposite direction where we'd go positive 1 and left 1, 2, 3. Now, if we go back up here, it says that x is less than or equal to 3. So that means that my line, normally we would draw my line and it would go right and left with arrows at both ends, correct? But since x has to just be less than or equal to 3, that means I'm only going to draw my line going to the left. it doesn't always work out that when I'm drawing my line or my graph that this point actually gets put on it. Sometimes we have to plug this value in and solve. This time we just lucked out, okay? All right, so that took care of the first function. Are there questions on that first function before we move to the next? Bless you. Okay, so this next one, there's just a 4. That equation, I would write this as y equals 4. What type of graph will that be? It is also a line. What type of line? Is it going to go right and left or up and down? Very good. It's going to go through the point y equals 4. So it's going to go right and left. Now it's saying though that it's y equals 4 only if x is greater than 3. Will that be an open or closed circle? Open. Okay, so I'm going to go on the y-axis. I'm going to go up 3, up 1, 2, 3. Okay? And then I'm going to go over here, and it's an open circle. So this is the whole line, y equals 3. But it only goes to the right. Because they told us that x has to be greater than 3. So for y equals 4, it would normally be this whole line right there, correct? But we're only using the piece that's to the right, the piece that's greater than 3. And so that is why I have an open circle going to the right. Okay, do we have questions on either pieces there? G. Because I can't count. That's a candy for G. Okay, it should be up how many? 4. 1, 2, 3, 4. Open, going to the right. Good catch. Thank you. All right, other questions? Hopefully that makes more sense now. I just didn't count right. Did I count right now? No. Did I do 5 now? No. Okay, phew.
Why did you go up 4 right there?
Say that one more time.
How come you went up 4 there and not 0?
I actually did go up 4 from 0. So y equals 4, I would go up 1, 2, 3, 4. Okay, and this is my actual whole line. Like normally I would write this whole line as y equals 4. But it's telling us that it's y equals 4 only when x is greater than 3. So remember how we have this boundary? So 3 is where it's starting, and it doesn't equal 3 because it doesn't have the line underneath it. So that's why I have an open circle, and then it's everything to the right. Okay, other questions or clarifications? Okay, so now we have to write the domain and range. So remember, domain is going from left to right, your x values. Okay, so remember, domain is x, range is y. Okay, if you forget that, write it down each time you do it. That domain is x, range is y. Okay, domain is going left to right. This is my x-axis. So if you see how this has the arrow going to the left? That means that for your domain, it's going to negative infinity. You always go smallest to largest. So we have negative infinity. Now, see how it changes here? But do you see how this point, even though it doesn't equal here, it equals here? So that's still included. So what happens is the domain actually goes from negative infinity to positive infinity. So even though it changes, there's still a value. Okay, so now let's look at our range. So looking on my y-axis, my up and down, okay? This is my smallest y value. Do you guys see that? And so what value is that there? On the y. So you're looking at the y. So you're looking at over here, what value is that on the y-axis? 1. And it's solid, so it's a bracket, 1. And then on the y, it ends up, it's going up this direction, right? And so it's going to go up to positive infinity. And so that's my range. Another thing I want to tell you is that this is called a discontinuous function. Why do you think it's called a discontinuous function? Because continuous would mean it just flows. It goes on perfectly forever. And since there's breaks and shifts, that's discontinuous. It's disconnected, right? Disconnected would mean it's not continuous. Okay, anything else we want further explanation on that example? Yes. Okay, so remember that your range is like this up and down. So if I'm looking for my smallest up and down point, this point is the smallest point for up and down values. From this point, you have to go over and be like, okay, what value is this point on the y? And this point is at the 1 on the y. Okay, and so that is the smallest y value is 1. And then it goes up to positive infinity, so that's why it's positive infinity. Is that better? Okay. Anything else? Yes. So whenever you're writing your domain and range, you're always going smallest to largest. So yes, you're always going to start by looking for whatever the smallest value is, which could be negative infinity, all the way up to your largest. Okay? Other questions? Okay, so let's move on to the next one. Okay, so starting with our first function. And actually, even before your first function, what is going to be my boundary on this one? 0. So let's kind of make a dotted line here at 0 to remind us that my graph is going to be different on the left and different on the right. Okay, because 0 is right here. They're telling us my boundary is at 0. Okay, now we're going to start with my first function here. And what kind of function is that? Very good. So I'm just going to write down absolute value. So when I'm doing this, I remind myself, do you remember what kind of graph an absolute value is? A V. Okay? So this is my absolute value function. And when we are graphing an absolute value function, what's the first thing we should probably do? Very good. Find the vertex. And for this problem, what is my vertex? Negative 2, 0. Another thing to pay attention to is the direction that this absolute value graph would go. What direction would this graph go? Down. Yeah. Left as well because of the less than 0. But specifically on this one because, and how do we know it's going down? There's a negative in front. My A value is negative 1. Okay, so let's go ahead and plot this. So we're going to go left 2 and up 0. And we know our graph is going to end up going down. If you wanted to do your A value where you go negative 1 and you go right and left 1, remember that A equals negative 1 over 1 here. But we need to know specifically for sure at what point it hits 0. So, because 0 is my boundary. So what we would do is we would plug 0 into our equation and find what y equals. So I have y equals negative absolute value of 0 plus 2. What is 0 plus 2? 2. Okay? And then what's the absolute value of 2? 2, but then there's a negative in front, so it ends up becoming negative 2. So that ordered pair is 0, negative 2. I plugged in 0 for x, and then I got the answer of negative 2. So at 0, negative 2, will that be an open or closed circle? Open. Why is it open? There's no line, and that's what I'm dealing with right now, is this function, and there's no line here at 0 right now, so it's going to be an open circle. And then we're going to draw our v, okay, for our absolute value function. But we're starting at 0 and we're going left. So my v goes up to my vertex and then it goes down and it's continuous going down to the left. So that is how I draw my function there for my absolute value for x is less than 0. So I plotted my vertex, right? Okay, and you could do your A value, but you don't have to. And then we have to figure out specifically where does it hit at 0, and we plug that in to find that point. Okay. Do we need any clarification on this part? Nope, we're good? Okay, so let's move on to the next function. So the next function we have is y equals x squared minus 2. What type of graph is that? Very good. It's exponential. No, it's not exponential, sorry. It's a parabola or quadratic. Okay, and the parabolas are U-type graph. Will this graph go up or down? Up, and how do we know it's going to go up? Because there's no negative in front. A is positive. So I like to just kind of make notes to myself so that when I'm graphing this, hopefully I do it correctly. What's something else that I probably need to write for this? My vertex. What is my vertex on this problem?
0, -2.
0, -2 is correct. So remember that there's nothing in parentheses with the x squared. So that means the x value is 0. And then at the end, that's your y value of the vertex, which is -2. So if we go to 0, -2, you notice we already have that point there. But on this one, it has an equal to sign. So we're going to end up filling in this -2 for my parabola graph. It just happens that they end up being at the same point. And then I already have my boundary marked, don't I? And I know with the parabola, it's going to end up going up. And if you want to, you could do your A where you're going up 1, and I'm only going to go right 1. I'm not going to go left 1 because x is greater than or equal to 0. So for my parabola, it's just going to curve up like that. So for the parabola, I did my vertex at 0, 2. You can use your A value, and my A is 1 over 1, so up 1, right 1, and then make my curve for my parabola. And I'm only curving it on the right side because it is x is only greater than or equal to 0 for that. Any clarification on this part of the graph? Okay, I'm going to give you a chance to try writing your domain and range. Remember that you're looking at the whole graph. Okay, what do we think the domain will be? Good. Negative infinity to positive infinity is correct. If you're looking at your x going right and left, it goes for infinity to the left, and it also goes for infinity going right. Okay, your range, what will that be? Also negative infinity to positive infinity. Because if you look going down, it's going continuous down. And then again, it's also going continuous up. Okay, any questions or clarifications here? Okay. Notice on this next one, how many graphs are there? 3. Okay? There's also more boundaries. So let's mark each of our boundary lines. So one boundary is at what? 0. Another boundary is at 2. And then the last boundary is at 5. Okay, so let's start with our first function. And what type of graph will that make?
Absolute value.
Very good. Absolute value is correct. And absolute values make a V-shaped graph. Okay, what is one thing I would need to know for my absolute value graph?
Vertex.
Vertex. What is my vertex?
1,
Negative 2, 0. Whatever's with the x, think of absolute values also as parentheses. That will become a negative 2. There's nothing being added at the end, so that's why it's negative 2, 0. Is negative 2, 0 less than 0? Yeah, because on the x value is less than 0, because actually you're really just looking at the x. So we can go negative 2, 0 and make a point there. When you're making my a value here, first of all, what direction will my parabola be going? Or not my parabola, my absolute value? Up, and we know it's up because there's no negative, and my a value is 1 over 2. Okay, so I'd be going like up 1, right 2, possibly. Actually, it always works for absolute value, right? So from here, if I go up 1 and right 2, I end up on my boundary. Is that going to be a solid or open or closed circle? Closed. And we know it's closed because it has a line underneath. Good. How am I going to draw that now? We're going to do a V. So normally the V would go in both directions, like going up this way, but it has to stop. And then on this way, it's going to go that direction. So we've made a V for our absolute value. Questions on this one? Yes?
How come the point on the left only went up 1, up 1?
Because I didn't do it right. Okay, better? Good job. You can have candy too. Okay. Next one. Are we ready? Okay. No? Is someone gonna say no? Oh, okay, we're good. All right, so for my next function, we're gonna have y equals 2 to the x plus 1. What type of graph is this? Exponential. So remember, the exponential is like where it ends up like shooting up, and then it has that asymptote it stays close to. Okay. Now this one is interesting because it's only a piece of the exponential function, and it's between 0 and 2. So the easiest one for this is to just plug in 0 and figure out where is this function 0, and then plug in 2 to figure out where it is at 2. So we're going to plug in 0 first. So we'd have y equals 2 to the 0 plus 1. What is 2 to the 0? 1. And 1 plus 1 equals 2. So that ordered pair is what? 0, 2. So at 0, is it going to be open or closed? Oh, open, correct? Because there's no equal sign. So I'm going to go 0, 2, so 0 up 2, and I'm going to make an open circle there. Okay, now I'm going to plug in what value? 2. So y equals 2 to the second power plus 1. 2 to the second is 4. 4 plus 1 equals 5. So what ordered pair would that be? 2, 5. At 2, okay, at the 2, 5 point, is it going to be open or closed? Closed. So we're going to go right 2, up 1, 2, 3, 4, 5, and that will be a closed circle. And then remember, exponential, it's just like shooting up like that. So it's a slightly curved line, right? And so that is my exponential function. It's only that piece of the exponential function. Okay, so notice that it's only between 0 and 2. So if I found my value for 0 and I found my value for 2, I'm just going to make a little bit of a curve there because exponential curves and shoots up, right? And so that's it. That's all I'm going to do for that function. Do we need any clarifications? Good. You know something's exponential when you have a variable in your exponent. Okay? Parabolas only have a 2 in the exponent. Other clarifications? How did I get 0 for what? Because it's telling us that either the x is in between 0 and 2. So I'm plugging in 0 for x, and then I also plugged in 2 for x. Because I wanted to find, well, what does y equal when I plug in 0? What does y equal when I plug in 2? So you're going to be plugging those values in for x. Okay? Anything else? Okay. All right, my third one, my third function is y equals x minus 3 squared. What type of function is that? Very good. It's a parabola. How do I know it's a parabola? It has a squared term. Now, is this parabola going to go up or down? Up. Okay? One important thing with parabolas is that we need to know the vertex. What is my vertex on this? Good. 3, 0. We take what's inside with the x. It becomes the opposite. Nothing's adding at the end, so that's where I get the 0. Okay? And this boundary is in between 2 and 5. Is 3 in between 2 and 5? Yeah. So I can go ahead and make that point. So it's going to be right 1, 2, 3, and up 0. Okay. So there's my vertex. Since they have a boundary of 2 and 5, we need to figure out, well, what does this parabola equal at 2 and what does it equal at 5? So we're going to plug in those values into the function. So y equals 2 minus 3 squared. What is 2 minus 3? Negative 1. What is negative 1 squared? 1. So what is that ordered pair? Nope. What did I plug in for x? 2, 1. Okay? So at 2, is that going to be open or closed circle? Open. So we're going to go right 2, up 1, and I'm going to make an open circle right there. The other value I have to plug in is what? 5. So we have y equals, parenthesis, 5 minus 3 squared. What is 5 minus 3? 2. What is 2 squared? So as an ordered pair, that is what? At 5, 4. So looking back at your inequality up here, is it going to be open or closed at 5? Closed. And we know it's closed because it has an equal to sign. Okay, so I go over at 5 and up 1, 2, 3, 4, and I make a closed point. So from here to here, it's a parabola, so we're making our U-shaped graph, but it stops at both of those points because it's only between 2 and 5. So these problems, I feel, are not difficult if you just take it a piece by piece. Okay? Does it take a long time? Yeah. Okay, so that part is slightly annoying because it takes some work. But if you do it piece by piece, you should be okay. So last night's homework, you did one piece on one graph. Now we're doing 3 pieces or 2 pieces on one graph. Okay? So, domain on this one. What is my smallest x value? If you look at here, going left, it's going to go to negative infinity. Okay, going to the right. So we're going to keep going right. Okay, there is a point here for the x, so we're good. We keep going. There is a point here for the x. We keep going. And the largest x value is here at this point, which is at 5. And it's a solid line, so that means I use a bracket. Very good. Okay, for my range, okay, we're doing our y values. If you look, my smallest y value is right here, which is at 0. Is it solid at 0? Yes. So that means we'll use a bracket at 0. And then going up, do you see how this has a point and it's going this direction? So that means the range is actually going to end up going to positive infinity. And we close our parentheses. Okay, now it says f of -4. So they want you to go to where x is -4 and see what the answer is. So on our graph, if we go left, 1, 2, 3, 4, what is my answer? What's the y value at that? 1. So f of -4, the answer is 1. F of 2. If you go to 2 on the x-axis, what does y equal at 2? Not 1, because it's an open circle at 1. That point should be at 5. So at 2, y is 5. F of 3. If you go right, 1, 2, 3, what does y equal here? 0. Okay? Do we have any questions? All right, we ready to move on to the next one? So last one that's like this, and then we're going to be doing something slightly different for the second part of notes. Okay, so starting here, my first function just says 2. Okay, we kind of dealt with this yesterday, but we would write that as y equals 2. What type of function is that? It's a line. Very good. So that line would be at y equals 2. So on your graph, you would normally have a straight line at y equals 2 going horizontal, correct? But it's saying that at y equals, the function y equals 2 is only if x equals 1. So what am I going to do? What ordered pair is this going to end up being? 1, 2. Y will always be 2. And if you have x is 1, y is also going to be 2. So we're going to go right 1 and up 1, 2. And we are only making a point. We are not going to be drawing a line because they are telling us that x only equals 1. Okay? Is that okay with everybody? All right, so that one's done. That's nice. Our other function we have is y equals -3x plus 1. What type of graph is that? It's a linear, another line. Okay, when we're drawing a line, what do I need to know? Not a vertex. My m, my slope, which is -3/1, and my y-intercept, or b value, which in this case is 1. Good. So what I'm going to do is plot my y-intercept. So I'm going to go up to 1 and make a point. Okay, and from there my slope is -3/1. Okay, so if I go down 1, 2, 3, and right 1, I get to this point right here. And then I have up 3, left 1 to this point right here. But we need to look at my, oops, and we should have made it our boundary, shouldn't have we done that? My boundary is at 1. So on this line, the only instructions that they told us is that x cannot equal 1. So on this line, when I went down 1, 2, 3, right 1, I got onto that line. So what should I do there at that point? Yes, we would draw an open circle. That's the only information, the only thing that we have to worry about. So when you're drawing this line, you can draw this line, and the only thing is that on this line, x can't equal -1. I should maybe not use a pencil when I'm writing. Okay, so this is open here. All right, so your domain. What is going to be your domain on this? Good, -infinity to positive infinity. Okay, and the reason is that even though the domain it's open here, it's closed at this point, right? Okay, now looking at your range, because this one's a little different on your range. Okay, your range starts at -infinity. But when you're going up, there is an open circle at this point, and it's not like plotted in anywhere else on your y. So that means there's a break here in your range. And what value is this for your y? -2. So it goes from negative infinity to -2. It does not equal -2, so we have a parenthesis there. And then it keeps going, so this is where we do a union, okay? And it starts again at -2, and it goes on to positive infinity. So do you see how there's a break on the range? How it has that one open circle? And that's why we have to do a union, because there's a break there. Okay, f of 1. So when x is 1, what is the answer? 2. Very good. Not the open circle, but that point. It is 2. When f is 0, what is my answer? 1. Good. And when f is -2, it looks like it's what? I think it's 7. If you're ever not sure, okay, f of -2. -2 will fit into this equation, okay? And so if you ever need to check, we would plug in -2. So I'd write this as y equals -3 times -2 plus 1. What is -3 times -2? Good. And then 6 plus 1 equals 7. So f of -2, the answer actually is 7. Okay, any questions?
Wait, can you go back up?
Mm-hmm. So I just plugged -2 into my function. And I knew that -2 was in this one because this one, the only restriction was that it doesn't equal 1, so it had to fit in there. Okay. All right, any other questions on this one? Because it always connected. So like on this one, like when there was a y value missing here, there was a y value over here. And so if there was a y value missing here, but it connected here. So you only need a union when there isn't a value there. Okay? All right. Okay, so this one, they gave you the function and they want you to give them some information and also to write the piecewise function. Let's start though with A and B and even C. Okay? So for the interval -infinity to -2, so here's -infinity going this direction to -2 right here. What type of function is that? Very good. That's your answer for A. Absolute value. Because we know that absolute value functions make a V-type graph. And then it says from -2 to positive infinity, what type of graph does that make? Very good. A parabola. Okay, this C, it says identify the open intervals that would not be affected if an absolute value function was applied to the entire graph above. So they're saying, and if you think about this, okay, so we're going to pretend like these are absolute value bars. If they took the absolute value of this function, anything that's on the negative side would end up reflecting and going to the positive side. Okay? So basically, you know, we have this point here and here and here. Okay? So what would be affected? Or what wouldn't be affected? So identify the open intervals that would not be affected if an absolute value function was applied to the entire graph above. So from this point left, that wouldn't be affected by absolute value because it's on the positive side. So what interval is that? That is -infinity to, and what value is that? 1, 2, 3, 4, 5. -infinity to -5. Okay, and the reason why it is a parenthesis is that if it was -5, then it would take the absolute value of it. And so it's like kind of at your 0 point. So it doesn't actually equal that. Okay. Where is another point where it wouldn't be affected? Do you see from here to here how all of that is positive? So we would do our little union, and it's from -3, comma, and this isn't exactly on a point. For right now, we can find a specific value later when we have like an equation, but this is at what value? Approximately, what would you guess? 1/2. So we're gonna write that. And then everything else goes to the negative. Make sense? Okay, so let's try to write our piecewise function. Was there a question? That's what we had there. Do we understand how that worked? Yeah. Where's the negative infinity? So from here to here, okay, so this is at 1, 2, 3, 4, 5. So that's -5. So since this is above the x-axis, it's not negative. And so when you have this going, a line going in a direction, it's going to go -infinity all the way to -5, where it's going to stay positive. Okay, is that your question? So then -3, so if you go here, so then do you see how this is below the x-axis? That's on the negative side, so that would be affected by an absolute value. Okay? But then it starts to be positive again, and so at -1, 2, 3. So see from -3 right here, all the way to right here, which we said it's about 1/2, that is also positive. So it wouldn't be affected by absolute value. Did that answer? Okay. So your piecewise function, if you go back and look, when you have a piecewise function, okay, let's look at how it's written. It has f of x equals, and then it has each of your equations, and then the intervals, right? Okay, so we're going to have f of x equals, and we're going to have two different equations. You could do like your special, what are those called? Do you guys know what they're called? Some type of bracket parenthesis thing. It has a specific word. I can't think of what it is right now. Okay, so let's start with our absolute value function. How am I going to write this? We first need to know what? Vertex. What is that vertex? -1, 2, 3, 4, -1. Does everybody agree with that? Okay, what does it look like my a value in front is going to be? 1/1. And it's going up, so it's positive, so it's going to be +1. Are we okay with that? Okay. So how am I going to write that? We're going to not write y because remember we have f of x out here. So we're just going to start with our absolute value. So we're going to have absolute value of x what? +4. And then what? -1. And it's over the interval. And so either you can write if or of. I'm just going to put if. I don't know why I normally put if. And then what are the values? If x is what? So when does it change? It changes here at this value, right? What value is that? 2. So if x is less than or equal to -2. So that means on the other side, it's going to be, x is going to be what? Nope, it's going to still be -2, but instead of less than or equal to, it's going to be greater than -2. So to the right, it's going to be greater than 2, while to the left it was, right. And only one of them could have the equals. Could I put the equal to sign on this one? Yes. You could put the equal to sign on either one of these. It doesn't matter since they're both connected at that same point. But you can only have the equal to sign on one of them. It can't be on both of them. Okay, so now this is a parabola. In order to write a parabola, I need to know the vertex. What is my vertex there? -1, 2. Good. And so when I'm writing this, you know, we'd have y equals, and it's going to be x plus 1 squared plus 2. And what do you think the a value is in front of that? So if you're counting, it looks like it's going down 1, right 1. So we can give that a value of just a -1. And you can write that as -1, or you can write it just as a negative. But notice it's going down, so that would make sense why it's negative, correct? Okay, so over here, we don't write the y equals. I would just have negative parenthesis x plus 1 squared plus 2. If x is greater than -2. Okay, questions? Okay, this last part down here is that they want us to use the above function and they just want us to shift. So how is this going to shift? Right 2. So looking at the above function, we're just going to take each of these points. So this point, it's at left, we're going to go 1, 2, 3, 4, 5. So if we're at left 1, 2, 3, 4, 5, I'm going to go from there, I'm going to go right 2 and make that first point. Okay, so I went left 5 and then right 2 to make that first point. I need to make this a little smaller. Okay, so now this point right here is that left 1, 2, 3. So if I start at left 1, 2, 3, and then I move right 2, 1, 2. Okay, if you look here, this V point right here is at left 1, 2, 3, 4, down 1. So left 1, 2, 3, 4, down 1, and then I go right 1, 2. Wait a second. Did I do this right? Okay, and the point should be there. Do we agree? Okay. And then the last one I'm going to mark here is this point right here. It's at left 1 up 2. So if we go left 1 up 2 and then I go right 2, 1, 2, I have a point here. And then we're just going to draw the function and it looks like this. Okay, what does it mean when you have a negative x right here? How does it reflect? Good, that is reflecting across the y-axis. So now we're going to take each of these points and move them to the other side of the y-axis. So you know how this one was at 5. We counted that already, right? 1, 2, 3, 4, 5. That means I'm going to go to the right. 1, 2, 3, 4, 5. And if you want to even, this would end up going, if you were to start this graph, it's going to end up going out that way, right? Because it's reflecting over. Okay, this one is at 1, 2, 3, 4. Wait. Just kidding, 3. And then, so we're going to go to the right, 1, 2, 3. Okay, and we know that vertex is down 1 in between those. This one was left 1 up 2, so we're going to go right 1 up 1, 2. And then we can just end up connecting all these points. Oops. And then notice that this one, it curves through, you know, like at the -1/2. Oops. Okay. Is that okay? All right, absolute value. We kind of already talked about this. Do you see how at this 5-1, everything is positive, so it wouldn't change? It's just that anything that's below the x-axis will end up being reflected over the x to make it positive. So this is left 5. 1, 2, 3, 4, 5. I'm going to make that point. And then we had left 3. So we have 1, 2, 3. Now this point that's down below, if you were to take the absolute value of that point, it would end up going up across the x-axis and be a positive 1. Okay, and this other point's at a half. We're going to keep it there at a half. But what's going to happen is, so like this V ends up going above. This point right here where it goes down below, it's going to end up going up. And then everything that was positive is going to stay positive. And that was at 2, 1, right 2, up 1. And then this one's going to stay up. So when you take the absolute value of a graph, anything that is below the x-axis reflects above and goes to the y-axis. So your final graph ends up looking like that. Okay, questions? Okay, we're good? Okay, last one. This has been long, I'm sorry. Okay, a shipping company has a flat fee of $4 per package. Remember that when you're reading word problems, it's good to have a highlighter or underline, but I'm gonna go ahead and just write a flat fee of $4 per package for packages up to 2 pounds, okay? Plus an additional charge of $3 per pound for any part of that pound above. For example, a 1 pound package would cost $4, and a 2.5 pound package would cost $7. Or sorry, 2 1/4 pound would cost $7. So we're only going to go from 0 to 6, okay? It says A to x represents the total cost, okay? A to x meaning your function, where x is the weight of the package, okay? So which one is going to be the weight, like your x or y axis, and which one is going to be the cost? So one's going to be the cost, one's going to be your weight. What do you guys think? Say that again. Very good. Your cost is going to be your y value because that's your function, your a of x. Okay, and your weight is your x value. So let's think about this. So it says a flat fee of $4 per package for up to 2 pounds. So first of all, if you're not mailing a package, that means it weighs 0, right? And so at 0, it's going to end up being at $4, but it's going to be an open circle because no one is going to mail nothing. Wait, or everyone mails nothing. I don't know. You can think about that. Okay, but it costs $4 for any package, any weight, up until what weight? 2 pounds. Okay, so at 2 pounds, it is going to cost $4, and anything in between, it's also going to be $4. Does that make sense? Why it would be a straight line like that? Okay, then it says it's going to be $3 per pound or any part of that pound. So for each additional pound, it's going to add $3. So what's going to happen from the weight of 2 to 3 pounds? Hi. Thank you.
Math Excel.
Thank you very much for the delivery. Yeah. Speaking of packages, that weighed more than 4 pounds. Okay. Anyways, what do you guys think is going to happen? First of all, if the package weighs more than 2 pounds, between 2 and 3 pounds, how much money is it going to cost you? It starts at 4, but if it's more than 2 pounds, it's going to be an additional how much money? Okay, so from here I'm going to have to go up 1, 2, 3, which is going to make it at $7. Now, this is where you kind of have to think a little bit. If it's 2.5 pounds, it will be how much money? It's going to be $7. If it's 2 3/4 pounds, it's going to be $7. They're telling you that it doesn't matter if it's in between 2 and 3 pounds, no matter where it is, it's going to be $7. And so that is going to end up being another straight line from here to here. Now, if it's 2 pounds, if it's exactly 2 pounds, it's going to be $4. So it's going to be an open circle at this end. But if it weighs up to 3 pounds, it's going to be a closed circle at this end. So it's $7 if it weighs in between 2 and 3 pounds. What's going to happen if it weighs in between 3 and 4 pounds? Another $3. So I'm going to go up 1, 2, 3, and I'm going to be at 10. Now, if it weighs 3 pounds, it's $7. Okay, so it's going to be an open circle here, but anything above 3 pounds, it's going to be $10. So it's going to be another straight line up until you get to 4 pounds. So at 4 pounds, it's $10, but as soon as it goes a little bit over 4 pounds, what's going to happen? We're going to go up $3 more. 1, 2, 3 more dollars. Okay, and at the 4 pounds, it was $10, so we're going to do an open circle at this end, and then anywhere between 4 and 5 pounds, it's going to be the $13. And then from 5 to 6, because they wanted us to do it from 0 to 6, we're going to go up $1, $2, $3. Is this going to be open or closed at this end? Opened. And from 5 to 6 pounds, it will be $16. Just so you guys know what this is called a step function. Doesn't it look like steps? Makes sense why it's called a step function. Okay, what is the domain on this one? So the domain, it starts at 0, because remember domain, we're looking at just the X values. It starts at 0. Is that open or closed at 0? Open. And it goes all the way to 6. And at 6, it's a closed. For your range, now we're looking at the up and down. What is the smallest range value? 4. Is that open or closed at 4? Open at 4. And it goes all the way up to, and is that open or closed? Closed at 16. Okay, now they want us to write the piecewise function. So remember, when we're writing the piecewise function, we write f of x equals, now this one's going to be larger. I'm not going to do the bottom because we have to state each of these pieces. There's that many pieces. What is that? 1, 2, 3, 4, 5 pieces. Okay, what is this? This is y equals what value? 4. So it's at 4 if x is what? In between what values? 0 is less than x is less than or equal to 2. So the answer is 4 if the weight is in between 0 and 2 pounds. Okay? So then my next function is right here. What value of y is it here? 7. If, and then what are the values for x? They're at 2 and 3, right? So 2 is less than x is less than or equal to 3. What's going to be the next value for y? 10. If, what? So at 10, the two values are in between what? 3 and 4. 3 is less than x is less than or equal to 4. Okay, what will be my next one? 13 if 4 is less than x is less than or equal to 5. And then my last one is if 5 and there's your piecewise function.